Next up, we have Joel Willis from the Department of Agriculture, Water and Environment. He's going to share with us a range of projects that they're working on at the moment in biosecurity risk, auto-detection, algorithms and 3D X-ray. Over to you, Joel.
Thanks very much, Steph. I'm just going to share my screen here. Okie dokie, so hopefully you can see that. So as Steph said, my name is Joel Willis. I'm the Director of the Detection Capability section within the Biosecurity Operations Division at the Department of Agriculture, Commonwealth. My team looks after 3 streams of work. We look after the department's Detector Dog program, also our detection capability component focused on X-ray. And we also have a new body of work, the Biosecurity Operations Division's Emerging Technology program. So today I'm going to go through a few things. The Biosecurity Operations Division's Emerging Tech program incorporates a wide range of projects focused on risk detection tools and emerging tech. The projects aim to deliver a more seamless border experience and to improve the detection of biosecurity risks across the international traveller, mail and cargo pathways. There's about 15 projects overall that fall under this program of work, but today I'm going to give you an overview of a few of those, including our automatic risk detection algorithms and their use on 3D X-ray, a new pre-screening of passenger baggage project, an inspection robot that is affectionately called the Bug, and a proof of concept we're doing using AI to identify imported fish. So to set the scene a bit, 2 years ago, the department commenced an innovation trial where we took the existing screening technology used for dangerous goods detection and said, you know, look, why can't we apply this to biosecurity risk items? So, you know, when you go through an airport and your bags are scanned and they're loaded onto the plane, and the X-ray screening that is done there applies auto detection algorithms looking for things like explosives. So in partnership with Rapiscan Systems and New Zealand Biosecurity, we embarked on a 2-year program of work to develop algorithms that can detect things like fruit and meat in bags and parcels. So to facilitate that, the department purchased 3 3D X-ray units from Rapiscan. 1 unit we have permanently installed at Melbourne Airport's jet-based facility for R&D purposes, and the other 2 units are permanently installed at Australia Post's biggest mail centres in Melbourne and in Sydney. Using the 3D algorithm technology, the program so far resulted in algorithms for fruit, fish, meat, plant and veggies. The fruit and meat algorithms are doing really well, hitting around 70 or 80%. There's really good results with the algorithms under continuous development. And the more data we feed into the system, just the better and better the algorithms get. We're now expanding into the illegal wildlife trade as well. So to date, we've concentrated mainly on commonly trafficked Australian species such as lizards and snakes, but now moving into things like ivory and rhino horn and tortoiseshell. So if you look at this slide here and the image, it just shows the difference sort of between 2D, X-ray, 3D and algorithms. So this picture here in the orange is that it's all the same bag, and it's a 2D image of vacuum wrapped Chinese sausages. And if you compare it to the image directly below it, you can already see how much better we're able to get an idea of what's in the bag using the 3D technology. And when we overlay the algorithm software on the 3D image, you can see how the task becomes even easier for our biosecurity officers as the software is thrown a bounding box around the meat to really highlight it. So it's not surprising that 3D X-rays have proven to be 2 to 3 times more effective than 2D X-rays at helping us identify biosecurity risk items. In conjunction with our work on 3D X-rays, we've also been collaborating with Rapiscan to improve detection of seeds. seeds present a real challenge for us in the way they're often very difficult to detect due to their small size and the way they're packaged. The 3D X-rays themselves, they're big units, they're set to really high energy, and that allows us to identify bigger risk items. But they're simply too powerful to detect things like seeds. They virtually become invisible because the X-rays just shoot through them. So we've been piloting a low energy, high resolution solution to identify seeds in mail items. So the tech has proven really effective. And you can see some images there on the screen of that. And we're now, over the next 6 months, we'll be testing this in an operational setting. So moving from the prototype into, converting it into a conveyor system that you would normally see in a mail centre, and using it in a live environment. I'm now going to play a short 2.5-minute video, so you can see the algorithms and the tech in action. Depending on your bandwidth, it can be either really smooth or a bit glitchy. So hopefully it plays okay for you. Here we go.
The department has a growing biosecurity problem. We are required to screen more, be more efficient, be more flexible, manage emerging and emergency threats. But we have limited resources. So we turn to technology for a solution. We have procured the RapidScan RTT 110. It is a 3D X-ray or CT scanner. This unit has a stationary gantry and sends X-ray beams from up to 270 points simultaneously whilst the object moves through it. The outcome is a 3D image sent instantly to our officers' screens.
This now is the 3D X-ray image. We can rotate and change angles to get a better view. We can crop and slice the image, remove any items that might be obstructing our view. We can zoom right in on the potential target and make a really confident decision if we can clear the parcel or send it in for inspection.
The 3D X-ray technology also supports the deployment of auto-detection algorithms. In partnership with Biosecurity New Zealand and our supplier RapidScan, we have built the world's first algorithm for the automatic detection of biosecurity risk material. We can now automatically detect fruit, meat, seafood, vegetables, and plant material. At the moment, we're working on the world's first algorithm for identifying illicit wildlife trafficking.
The wildlife algorithms are currently being developed and trialled on our 3D X-ray units at the border. The current trial is using algorithms to detect reptiles and will be enhanced in the short term to detect other species. The algorithms can be used in either the mail or cargo environment for inbound or outbound screening, as well as in international airports when screening passenger baggage. The algorithm software acts as a threat engine that analyzes the image data across several different data points contained within the image, like shape and density. From there, the algorithm determines if a threat is likely to be present, which is highlighted by using a bounding box around the threat and tagging it as wildlife.
When the first unit was installed into Melbourne Airport, we didn't even know if it was going to work. Now 3D X-rays and auto-detection algorithms form the baseline of modernisation of our border screening technologies. The risk of innovation is that it might not work, but the benefit is that it might just change everything.
Okay, so utilising the success of the 3D X-ray and auto-detection algorithms projects, we're now going further beyond our mail centres and expanding into a trial for the pre-screening of passengers' checked bags. So, as you know, the current state is a passenger collects their checked bags from the baggage carousel and then moves through biosecurity screening before exiting the international airport. We're about to start a trial that will change this process. So the pre-screening of passenger bag projects is split into two streams of work, an onshore proof of concept and an offshore proof of concept. The onshore component will install a 3D X-ray back of house incorporated into the baggage handling system to facilitate the clearance of passenger bags by biosecurity on their way through the baggage handling system to the collection carousel. And the offshore component will take this a step further and use image transfer from outbound aviation security screening to do this. So to go into a little more detail, passengers' checked bags will pass through the X-ray unit after they're loaded onto the conveyor system by the baggage handlers, and the bags are either tagged using the IATA bag tag or an RFID sticker, the combination of a biosecurity officer assisted by the algorithms will make a decision on which checked bags are cleared of biosecurity risk and which bags need secondary inspection. All this is done prior to the passenger collecting their bags at the carousel, and importantly, this proof of concept is country agnostic. Both Brisbane and Melbourne international airports have agreed to partner with us for this project, and we're in the very early stages of planning with those airports. The offshore component of the pre-screening project will take X-ray images from outbound aviation security in New Zealand and use those images to clear the passenger bags while they're in flight. So the proof of concept will use 2D X-ray rather than 3D, as that's what's currently being used for outbound aviation security screening in New Zealand. But they are moving to 3D, but we understand this is a couple of years off. Whichever method is used, the experience for the passenger should be the same, in that their checked bags have been assessed and collected before they get them on arrival. All this biosecurity work around algorithms is fantastic, but it's ideal, obviously, to share this technology with our partner border agencies. So we're working with Rapiscan, an Australian Border Force, and New Zealand Customs to explore the use of this technology for customs risk material, in particular things like weapons parts, and narcotics. So New Zealand Customs are commencing a trial later this year on auto detection algorithms for narcotics, and Rapiscan are working with in the UK and out of Dubai, I believe, on data collection for weapons in order to build that extra functionality. In terms of 3D X-ray hardware, we currently have, as I said at the start, a couple of units permanently installed at the Australia Post facilities in Sydney and Melbourne International Mail Centres, and that R&D unit as well. The 2021 federal budget has provided funding for 3 more units for our mail centres and 2 units for the pre-screening of passenger bag trial. So really exciting stuff. So we'll over the next 20 months or so, we'll be expanding from 3 of these units up to around 9. And we're also exploring options to partner with industry rather, to install a unit to an air cargo facility, which is somewhere where we haven't played before. So apart from algorithm development for use with X-ray tech, we are also using artificial intelligence to support our job in other ways as well. For example, over 10 million live fish are imported into Australia every year, and amazingly, our biosecurity officers inspect every import to ensure that the species in each consignment are permitted. The differences between some permitted and non-permitted species are really minor. For example, if you look at the 2 fish on the screen there with the tick and the cross, you can imagine how tricky it is to tell them apart if they're swimming around in a bag of water with 50 other fish. It's easy to see in that circumstance why mistakes can sometimes occur and non-permitted species are inadvertently released to importers. So the department is leveraging some work on AI algorithms that have been developed to identify Australian native fish in Kakadu National Park. And through an innovation project in agriculture, the team are expanding the algorithms to include exotic fish species for import. If successful, they'll be deployed via an app, and fish inspection and species identification will be as simple as pointing a mobile phone camera at each bag of fish. It's a 3-year project that's going to require collection over 140,000 hand annotated images to build the algorithm. It's a lot of work, but ultimately the result will be a much more accurate detection of non-permitted fish species, and potentially, importantly for us, faster inspections and better biosecurity outcomes. As well as X-ray and AI technology, we're also trialling other innovative ways to make detection of biosecurity risks not only easier, but really importantly, safer as well. In the cargo pathway, for example, our biosecurity officers often have to put themselves in risky locations, such as underneath vehicles and sea container inspection stands. We're in the early stages of working with New Zealand Biosecurity to trial what's essentially a remote control car that uses thermal and high definition cameras to detect biosecurity risk. The unit can easily get into crawl spaces that are otherwise really difficult for our officers to get to. So you can see on the screen there, that second picture is one of the units underneath a Toyota Hilux. And that shoots images back to their handheld remote control unit. So we've just purchased a handful of these robots, and we'll be deploying them to various areas around the country in a trial capacity over the next 6 months or so. So as a department, I believe we really embrace the opportunity to innovate and research and trial new ways of doing our job. But none of this cool tech that I've shown and innovation is possible with our partners, and just a few of those partners are displayed on the screen. I think the challenge in front of us is not just to seize the opportunity to explore new things, but also to commit to realising the benefits of that innovation. And I think there is a lot of work that remains in front of us as a department to transition through some of these trials through to operational implementation. And that's been realised through the 3D X-ray work, but some of this other innovation, I'll be really keen to see that flow through to operations. Thanks very much for listening. If you'd like to get in touch after this forum, there's an email address at the bottom of the slide, detectiontech@agriculture.gov.au, and look forward to hearing from you. Thank you very much, Steph.
Thanks, Joel. So again, opportunity there to connect with Joel either via email or through the chat for the next few minutes while we move on to Brendan.